All right, P stats. This is part 2. So let's just continue on right on to where we left off here. So 27, we have a sample of 100 individuals yield a mean of 27.2 and a standard deviation of 20. What is the probability of the sample mean being in the interval between these two? So it's a lovely thing that they actually provided me with the lower and the upper boundary for this. So what you're going to do is you're just going to take out your calculator here. So let me just pull this back up again. Whenever they're asked to find out the probability, you know that I'm going to be asking you to use the normal distribution, normal CDF. But one thing that we need to understand is that the standard deviation of the 20, well, that has to be divided by square root of 100, which is your sample size. So when you go to do your normal CDF, 28.2 and your upper is 29.7, your mean is 27.3 and your standard deviation will be 2, not 20 here, because you always must take the sample standard deviation and you paste that and it actually gets you the answer, which is A. And that's all you have to do for number 27. 28, as part of a promotion for a new type of cracker, free samples are offered to shoppers. We have a proportion with the sample independent trials, the proportion the next shoppers buy. How large n should be so that the standard deviation P is no more than 0.01. So it basically is saying is that the how large should n be so that the standard deviation of the P hat is no more than 0.01. We have a proportion of the free sample is 0.2, so we can actually find out the sample standard deviation by using the formula P times 1 minus P over N all square rooted. So they're really asking to solve for N here, and this can be no more than 0.01 here. So it should be less than or equal to 0.01. When you actually plug in P as 0.2, notice what you get is 0.2 times 0.8 divided by N, and that is going to be less than or equal to 0.01, and then you have to square root that. Let's try to solve this algebraically. So I am going to square both sides, 0.01 squared like this, which gives me even further 0.0001. So I have basically here, if I continue on, we have 0. And I'm just going to do this real quick. 0.2 times 0.8, 0.016. Oh, I'm sorry, 0.16. Sorry about that. That is N, and this should be, approximately less than or equal to 0.0001 like this. Now, if you divide both sides by 0.0001 and multiply both sides by N like this, you basically get N by itself. So you're just going to divide that by this answer right here, and you simply find out that the N cannot be, something that is anything more than 1600 is not going to cut it here. So how large should N be so that the standard deviation is no more than 0.01? I believe that it should be D for this one because that's the number that we get, and 28 is indeed D. When you do all the math, you get the answer right here. So N should be the largest possible sample size that we can possibly get should be 1600. A study of voting chose 663 registered voters. 72% said they had voted in the election. Election records show only 56% of registered voters voted in the election. So which of the following statement is true? So first of all, this is a sample, right? 663 registered voters at random shortly after an election. But 56% of registered voters voted in the election means that this is actually your population proportion and this is your sample proportion. So 72 proportion is the sample. Oh, when we're talking about sample and population, make sure that you do not forget that the percentages are the statistics and parameters because they're the values, the studies for the samples that we got. The 663 is obviously going to be your sample, not the 72%. So we're going to eliminate all of these, which doesn't really make any sense. So we're just, and the correct answer 29 should be C for this one because 72% is a statistic based upon those 663 registered voters whom you selected. 56% is out of the whole population. So it's a parameter. 30, the Gallup poll has decided to increase the size of the random sample voters about 1,500 to about 4,000. Okay, as the sample size increases, we should all know that the variability decreases. Reduce the variability of the estimate. Obviously, that's the one word that we want to go for 30. 31, suppose we select an SRS and is equal to 100 from a large population P hat, the proportion of successes in the sample. For which value of P would it be safe to use the normal approximation? So that means we are using NP is greater than or equal to 10, N times 1 minus P is greater than or equal to 10. Now, because we have a sample size of 100, I mean, imagine what's going to happen if you multiply answer choice A and B by 100. You're actually not. Ooh, actually, my screen has been frozen here a little bit, right? So let me first stop sharing the screen here and then reshare my screen. All right, so sorry about that. So 30, as I said, it was C because the variability decreases. So 31, we are going to multiply both of these proportions by N, but what you get is that this is just 1 and this is 9. They do not satisfy the rule of large counts. Therefore, we're going to eliminate A and B due to that reason. Now, D and E also we're going to eliminate because of this criteria. Now, notice if your proportion of success is 0.975 and 0.999 respectively, that means 1 minus P would be this. Now, when you take those two numbers and multiply by a sample size of 100, you can see why that's not going to be more than 10 or equal to 10. So therefore, the answer here would be C. Times 100 times 100. I mean, check for yourselves. They do not actually be, they're not greater than or equal to 10. So therefore, they're out of the choices there. So it's going to be C. That's the only one. And it's going to work because 0.85 times 100 is 85. I'm saying 8.5. And 0.15 times 100, which is the 1 minus P, that's still bigger than or equal to 10. The central limit theorem is important in statistics because it allows us to use normal distribution to make inferences concerning the population mean if the sample size is reasonably large. This is actually the correct answer that you want to go for because the magic number is 30. As long as the sample size is big enough, what the central limit theorem states is that we can use the normal approximation. If the population is normally distributed, well, we don't really care about the fact that the population is normally distributed. We always care about the sample size being large enough so that it gives us enough confidence to say that, hey, we can use normal approximations because the sample size is reasonably large. 33, the number of undergraduates of Johns Hopkins University is approximately 2,000, while the number of Ohio State University is approximately 40,000. A significant difference in the sample size is there. Sample random sample, about 3% of the undergraduates are taken. Each sample is used to estimate the proportion of all students at the university who owns an iPod. Suppose that, in fact, P is 8.8 in both schools. Which of the following is the best conclusion? The estimate from Johns Hopkins has less sampling variability. Oh, wow, this is so easy. So here, Ohio State University has a larger sample size. Larger sample size means the variability is smaller. So the estimate from Johns Hopkins, which only had 2,000, will have more sampling variability. So 33 should obviously be B in this one. Researcher initially plans to take SRS of size N from a population that has a mean of 80 and a standard deviation of 20. If she were to double her sample size to 2N, the standard deviation, the sample distribution from the mean would be multiplied by. Okay, guys, so here, when you take the sample size N, you get a result of standard deviation of 20. So let's just assume that there is a standard deviation, okay, which you divide by square root of N, but that eventually ends up being 20. Now, you don't know what this population standard deviation is, but you can actually solve for that by multiplying both sides by square root of N. So the standard deviation, the population standard deviation would be same as saying 20 times square root of N, whatever N may be. Now, imagine for a second what happens when you take this standard deviation and apply the sample size of 2N in there. That means that the sample standard deviation would be 20 square root of N, because that's your standard deviation, divided by square root of 2N. Now, notice how the square root of N's will just cancel each other out nicely. And now from your original standard deviation of 20, how did it change? Well, you still have the 20, but now it's being divided by square root of 2, because remember, square root of N's have been canceled out. So what did you multiply by? You multiply by 1 over square root of 2. Because if you take that and multiply by 20, your actual initial sample standard deviation, you end up getting your final result for your doubling the sample size standard deviation. Okay, so that was just a simple algebra question. 35. We have a what is it? Sample size 250. Do you favor eliminating the carnival from the term end celebration? 150 of the 250 are in favor. So what is that? 3 out of 5. So that's about 60%. Suppose that unknown to you, 55% of all undergraduates favor eliminating the carnival. So that 55% means that's your P. This is your sample proportion. If you took a large number of SRSs of size n is equal to 250 from this population, the sample distribution of the sample proportion would be. So first of all, because we have a large sample size and with the P of 55%, you can use a rule of large count to prove that this is actually going to give you a normal distribution curve. So we are never going to say exactly normal. We're not going to say heavily skewed. It's really between B and D for this one, approximately normal, with the mean of 0.55, obviously, because that is your proportion for the population. And the standard deviation of 0.03, I mean, we can figure that out by just multiplying these numbers together with 250. And you square root that. So I'm just going to verify that this is actually going to be true here. So 0.55 times 0.45 divided by 250, and you square root that number. And yes, indeed, you do get a standard deviation of 0.03 right there. So the correct answer for 35, yes, it should be B. All right, so 36, which of the following statements about the sampling distribution of the sample mean is incorrect here? It says the standard deviation of the sampling distribution will decrease as the sample size increases. That is absolutely true. That's the same statement that I've been saying over and over again for the past couple of questions. The standard deviation of the sample distribution is a measure of variability of the sample mean among repeated samples. That's correct. So it's not an incorrect situation. The sample mean is an unbiased estimate of the true population mean. That is true. The sample distribution shows how the sample mean will vary in repeated samples. The sample distribution shows how sample mean will vary. The sample distribution shows how the sample was distributed around the sample mean. All right, so the wording of this can be confusing here, but we're talking about which of the following is incorrect. So the sample mean is an unbiased estimator of the true population mean. Technically speaking, since you probably want to have the word randomized in there, but since we're just probably going to assume the simple random sample for this. So for 36, I'm just going to eliminate this one right here. The sampling distribution shows how the sample mean will vary in repeated samples. With these two, the sample distribution show how the sample mean will vary in repeated samples. And the sample distribution shows how the sample was distributed around the sample mean. Okay, so the reason why E is the one that's incorrect between these two is because when you read this carefully, the sample distribution shows how the sample mean will vary in repeated samples. Every sample will give its own respective sample means, and it's all going to vary. They're all going to be different. But if you say the sampling distribution shows how the sample was distributed around the sample mean, how the sample was distributed around the sample mean, the wording of this can be a lot better, and I really just do not like the way that it was stated. But if I had to pick the lesser of the two evils, or in this case, the more evil, because I'm trying to select the one that's incorrect, the definition of the sample mean, or from the sample distribution, they have a variability because every sample is different in its own regards. I mean, they will have different values in there. They could have the same thing, but it's most likely turn out they're going to be different. So they will vary. So that's the word that I would really like to go for. So that sounds just more correct. The sampling distribution shows how the sample was distributed around the sample mean. I can't give you guys a clear answer as to why that wouldn't be the case, because when you do these trials over and over again, the sample shows how the sample was distributed on the sample mean. I don't think it's the sample. It's a statistic based upon the sample was distributed on the sample mean. If you're taking this, like the sample is the sample size, right? That's like the actual number of how many it's within the sample. You take the statistics, whether it's mean or standard deviation, and those values will be centered around the sample mean for all of those cases, well, in the sample distribution, but it's not the sample that was distributed around the sample mean. I know the wording of that can be a little bit confusing, but that is the best way that I could explain it at the moment. And it's just D is definitely the definition of how the sampling distribution works. I mean, the sample mean will vary depending on the samples. This word here for sample, that's what I really don't like about E. So 36 E would be the worst choice if I had to pick amongst the 5. 37, guys, it's going to be a typo, so please keep this in mind. And I'm sorry, but then the screen froze again, so I'm going to stop sharing the screen. Oh, actually, there we go. So 37, it's going to be a typo, and the correct answer here is going to be C. It's not going to be E. I'm not sure why they said 37 was going to be E here. A machine is designed to fill 16-ounce bottles of shampoo. That's just a description of how the shampoo works. You have a mean of 16.05 with a standard deviation of 0.1, which means when you take this 0.1 and you take a 4 bottle as a sample size, you divide by square root of 4, which gives you 0.05. Your standard deviation is 0.05. Now, since they give you already the percentage, you might be thinking of using, oh, wait, let's use inverse norm. But you don't really have to, because this is part of your empirical formula that states 68, 95, 99.7. 95 means you're moving 2 standard deviations away from the center at 16.05. So if you actually move 2 standard deviations away from 16.05, that will be 16.1, then there will be 16.15. Then if you move 2 standard deviations from the left of 16.05, that's 16, that's 15.95. So the correct answer is anywhere between 15.95 to 16.15. All right, so free response questions. This is what I did with you guys today. So I'll just go over this with you guys one more time very briefly. What is the probability that a randomly selected gallon of tea will have at least 2.3? So probability, we're using normal CDF. We are going to have at least 2.3, and then you guys can just put 10 with the mean and a standard deviation of 0.4. So with those numbers, I can actually just type them in. 2.3, upper 10, 1.8, 0.4, paste, bam. So that's the probability of 0.10564. Now, when you do part B with normal CDF, this is the part where I said I really don't like the way that they phrase these words. We have a 10 gallons of tea, which means our standard deviation will be divided by square root of 10. So 0.4, which is our original standard deviation, we're going to... Okay, so 0.4, we're going to divide by the square root of 10, which is a sample size. That's going to give you a standard deviation of about 0.126. Now, for the mean and the standard, well, I'm sorry, for the lower and upper boundary for this, we're talking about will be at least 23 cups, given the size of the gallons of tea to be 10. But that is 23 cups from 10 gallons and not 1 gallons per. And that's what we're talking about here. The amount of sugar per gallon of sweet tea. So 23 cups in 10 means 2.3 in 1 gallon. So that will be the same as before. So my Chrome is not working again. Hopefully, oh, I can't type anything. So I'm just gonna go back to this. So I'm going to use normal CDF one more time. So normal CDF with 2.3, 10, 1.8, and 0.126 this time. So the only thing that really changes is the standard deviation. So this gives me about 0.0000362. And that should be the correct answer for part B. They actually rounded up to 0.00004, but that should be the correct answer for this one. 39. Well-known food chain believes that 36% of their customers prefer to have their buns used on their sandwiches toasted. Suppose a random sample of 400 is gathered. So N is 400 and probability is 36%. What is the mean and the standard deviation? So the mean of the proportion would be 36% or 0.36. And the standard deviation of the proportions would be P times 1 minus P over square, 400, and then you square root the whole thing. 0.36, 0.64 over 400. You multiply those two, you square root the whole thing. So let the calculator do the work for you. Square root of 0.36 times 0.64 divided by 400. And what do you know? We get 0.024 for that one. And check to see if a normal curve is reasonable. Guys, we have n times p greater than or equal to 10, n times 1 minus p is greater than or equal to 10. So that will be 400 times 0.36. Obviously, you can tell me what that number is. It's going to be greater than or equal to 10. 400 times 0.64 is obviously also going to be greater than or equal to 10. Sorry, that just keeps on scrolling up. So that should be 10 here. And so both of these will check. So that allows you to assume normality because of the rule of large counts. Last question, what is the probability that fewer than 32% of the customers prefer to have their sandwiches untoasted? So that is, again, a normal CDF question with a lower boundary being actually 0 because we're talking about fewer than 32%. So the higher boundary will be 0.32. The mean here we found that was 0.36, and the standard deviation we found that was 0.024, or I'm sorry, was it 34? I'm just gonna guess. No, it was 24, I believe. Yeah, it was 24. So that probability here, I think, is 0.0477. They approximated it to 0.048, but I'm just gonna leave it like this. So about 4.7% chance that that is going to happen. Question 40. All right, so only a couple more to go. 40 is which statistics would provide the best estimate for the parameter? If you take a look at the answer key, it also says it, but quite honestly, the major difference between these three distribution curves is that the A has the lowest possible variability for A. And the center is also along the center, the mean is also along the center of the distribution. So therefore, you want to pick A. Obviously, the answer they said was both statistics A and B appear unbiased. So unbiased estimate, sample mean, because it's centered around the center of the distribution. The other thing that they said was, in addition, statistic A has lower variability than B. So C is obviously the worst case scenario because the center is not even on the center of the distribution curve. So A is best because in comparison to B, it has a lower variability. 41, the amount of the household pays service providers for access to the internet varies quite a bit. So that is the mean, that is a standard deviation. Many households pay about $10 for limited, $30 for unlimited. So I don't know what those two things are for, but we're just going to leave it there. A sample survey asks us SRS of 500. Now, I told you guys I want to explain this to you guys in the video, but 41, explain why you can determine the probability that the amount of randomly selected household pays for access to the internet exceeds $29 is because they say specifically this: the distribution is not normal. This distribution, they're pertaining to the population distribution. Now, why can't you just assume normality using the n greater than or equal to 30 using central limit theorem, because obviously the proportion is not stated here? Well, that is really meant for D here and C. We're talking about the sampling distributions, right? There's a word sample here. But the reason why we can't do for part A is because part A is talking about the population. The population distribution, you don't know. You don't know whether it's going to be normal. Actually, better yet, you know it's not normal. So you can't assume that normal CDF is going to be a fair game here because you don't simply know the shape of the distribution. Therefore, you cannot determine the probability of how many, like what's the percentage of the household that pays over $29 for internet. And for 41, that is basically what it says. You cannot calculate it because the shape is not normal, because the shape is not given. Normal, yeah, so I already wrote that down for you guys there. What are the mean and the standard deviation of the sampling distribution of X? The mean of X, well, we know that that mean of the X is $28. It's the same as the population mean. The standard deviation, obviously $10, but you divide by square root of 500. So let's do that real quick on our calculator. What is our standard deviation? 10 divided by square root of 500. And bam, we get 0.4472. So that is our standard deviation. What is the shape and the sampling distribution? You guys can probably already guess at this point that that is definitely going to be normal. Well, how do you know that? N is greater than or equal to 30. You tell me that it's a central limit theorem. As long as the sample size is big enough, as long as it's big enough or more than or equal to 30, it satisfies the central limit theorem and states that you can assume normality for this one. Part D, find the probability, obviously normal CDF, that the average fee paid by the sample of the household, again, by samples, you can do these, exceeds 29. So 29 with the standard deviation is that. So I don't know, maybe 50. 28 comma 0.4472. So we're going to go to our lovely calculator. Second varies, normal CDF, lower is 29, that's 50, 28.447 with the standard deviation. Paste that. All right, so we get about 0.0126. Sorry, I'm running out of space, but you get the idea. 0.0126. And I believe that should be the correct answer for 41 part D. 42, according to the government data, P is 22%, 0.22. Study of learning early childhood chooses SRS of 300. Find the probability that more than 20% of the sample are from poverty household, it says. So it seems to me that this is a normal CDF. How do I know that? 300 times 22% exceeds 10. 300 times 0.78 exceeds 10 as well. Please check for both. That should make sense. So normal CDF of lower and upper boundary, we're talking about more than 20%. So 0.21, 0.22 with the standard deviation of 0.22 times 0.78 over 300. And we're going to square root the whole thing to find the sample standard deviation. 300. Square root of that. There we go. So 0.02391. So let's go to normal CDF once again. Lower is 0.2, that's 1, 0.22, 0.02391, paste, bam. So that comes to be about 79.85%. And that should be the correct answer for 42, I believe, as well. They say it's 0.7995, but in all honesty, it's the same as what we have because they rounded it up and we didn't. 43, we're combining the two. It says, what is the mean of the sample distribution, the difference in the sample proportion? So what is the mean of the, what is it? 22% of the population weighs over 0.5 for the Western gray squirrel, about 36% population weighs over 0.5. Sample random 60 squirrels would be from the population of Eastern gray squirrels. So it seems to me that we are talking about what is the mean of the sample distribution. Okay, so let's see. 36% of the population weighs over 0.5 here. A random sample of 60 squirrels will be selected from the population and the random sample of 120. What is the mean of the sample distribution of the difference in the proportions of the East minus the West? So it seems to me that the proportion for the Eastern gray squirrel is 22, and we're talking about P at this point. So we're talking about the mean of the sample proportion should also be equal to that. And this is for the East. And for the West, 36%. So the mean of the sample proportion will be 0.36. What is the mean of the sample distribution of the difference in the sample proportions? What is the mean of the sample distribution? We're talking about East minus the West. So that's simply 0.22 minus 0.36, and 43 should be E. Yes. 44, city R is a large city with 4 million residents, city S with 0.25. You can read that on your own. Those are your population numbers. It says that city S residents between 10 to 25%. So I'm going to write 0.1, 0.25. City R is anywhere between 0.2 to 0.5. Suppose the two independent random samples of residents from each city will be taken. The proportion of residents who ride bicycles is recorded based on the population proportion of residents who regularly ride bicycles, which is the following sample size is large enough to guarantee that sampling distribution of the difference in sample proportion will be approximately be normal. N times P equals greater than or equal to 10 for both, please. N times 1 minus P is also greater than or equal to 10. This is what we want to check for. Now, right out of the gate, if I just use the 30 in city R, 30 in city R, 60 in city R, which will actually work, but 30 in city S. I mean, I'm talking about these numbers. There's no way, if I'm using the smallest possible proportion that it's because it's part of the range as possible, 30 multiplied by 0.2 gives you 6. There's no way that's going to fly in there because I need to make it greater than or equal to 10. Same thing with city S, 30 times 0.10 is even worse. So we're going to eliminate A, B, and C right out of the gate because when you use N times P, the rule of large counts, it's simply not bigger than or equal to 10. So it's really down to D and E, and the correct choice here will be, I think it's E. No, I'm sorry, it's D. So 50 in city R means 50 times 0.2. That actually meets the bare minimum criteria. 100 times 0.10 also meets the bare minimum criteria of 10. But when you swap up the order, 50 in city S, that gives me 5 when you take 10%. So E doesn't work. So the correct answer is D. N times P is greater than or equal to 10 is only thing you use for 44. 45, which of the following is the best explanation for why the sampling distribution can be modeled with a normal distribution? So we have survey random sample. Okay, so N is 45 and 55 for the population of 1,000. And okay, so 45 and let X2 represent 55. The two sample standard deviations are assumed to be equal. That has nothing to do with normal distribution. The sample sizes are sufficiently large. That sounds great because remember the rule of large count that allows us to assume normality. The distribution of populations are normal. Did it say that? I don't see that anywhere there. The population of standard deviations are assumed equal. Like I said, standard deviation has nothing to do with the normality of the distribution. There are at least 30 students in each of the two populations. Oh, I'm sorry. This is actually a lot better for the choice. So 45 here. Wow. So this is something that is very iffy. So the sample size are both sufficiently large. There are at least 30 students in each of the two populations. Division, okay. From population. The sample students ask how many hours they spend per week using any university computer lab. The distribution of the populations are normal. So, okay, so first of all, it's really down to B and E. Wow. Central limit theorem states that we can use normality for both. So which of the following is the best explanation for why the sampling distribution can be modeled with a normal distribution? Okay, this is a little iffy because I mean, central limit theorem allows us to, I mean, that's literally the definition of central limit theorem. There are at least 30 students in each of the two populations. Oh, I'm sorry. They have to say each two samples in order for it to make sense. Obviously, I mean, population can be 10 gazillion for all I care. I mean, two samples, the sample size has to be at least 30, not the population. So there we go. So that's why it's going to be B. Okay. So that was the issue with E. 46, the large school district held a district-wide track meet. So we have male and female. We have the sample for the female, 8.8. The mean, 7.3 for the male. So if we're doing female minus the males here, we can subtract those two and get 1.5. So we're really down to C, D, and E. Now take a look at the standard deviation of females and males, the standard deviation with the sample size that was given. Since no proportion is given here, the formula is the standard deviation divided by n plus standard deviations divided by n. I believe so. And this has to be squared, if I'm not mistaken. Right. And then when you add them up, square root the whole thing, you get the correct answer. So 2.9 squared over 8 plus 3.2 squared over 8. And we're just going to square root that to find out the correct standard deviation. So 2.9 squared divided by 8 plus 3.3 squared divided by 8. And square root the whole thing. 1.55 is the correct choice. So 46 is indeed E for this one. Cheryl practices hitting a softball in an indoor stadium by using both an aluminum and composite bat. So we have two things once again. So x1 minus x2. Which of the following conditions are sufficient to model the sampling distribution with the normal? So there are at least 30 recorded distances traveled for each type of bat. So each sample contains 30. Yes, that's a check. So which means I'm going to eliminate everyone that does not use the central limit theorem to prove normality here, because that's the main focus of this question. The distribution of distance traveled by the ball is approximately normal for each bat. If the distance traveled by the ball is normal, so the population is normal, that means the sample is also going to be normal as well. Total number of distances traveled is at least 60 for the two bats combined. I see. So here, the number of distances, they don't need to be at least 60. They need to be at least 30, like Roman numeral 1 said. So the correct answer here should be D. And by the way, you're really down to A and D. So since 1 and 2 both checks, you're just going to circle D and move on. 48. And I can't believe we are now finally at the end of this question. A polling agency is investigating the voter support for a ballot measured in an upcoming city election. Sample of 500, region A. We have the proportion, which is 0.47. What is the probability? So we're going to do normal CDF, lower and upper boundary, greater than 0.5, which is 0.5 to all the way to 1, which is 100%. We have the mean of 0.47, but now we need to find out the standard deviation by using the formula. And I'm not going to rewrite the formula once again. I think you guys all can figure that out on your own. So 0.47 times 0.53 divided by 500, square root the whole answer, and I get this lovely number called 0.0223. Normal CDF, everybody? 0.51, 0.47, 0.0223, paste, bam, and we have about 0.0892. So 8.9%, I believe the answer key, they said it was going to be 0.089. Yeah, there we go. The polling agency will take another sample from region B. Region B has 400 and 0.51 for the sample proportions. Describe the sampling distribution. So that means to talk about the shape, the center, and the spread. So the shape is going to be normal, obviously, but how do you prove that it's going to be normal? We're going to do n times p is greater than or equal to 10, n times 1 minus p is greater than or equal to 10 for the first samples, and 2p2 is greater than or equal to 10, and 2 times 1 minus p2 is greater than or equal to 10 for the second, which is region B. So let's just take a look at the numbers. I mean, we're talking about 500 times 0.47. Obviously, I think you guys can just, show that on the paper and check. We're talking about 400 times about half. That's 200. That's obviously more than 10. So shape is normal, check. Center is obviously super simple because we have region A 47, we have region B 0.51, region B 0.51 minus region A 0.47 gives me the mean of the overall to be 0.04. Sorry, my screen has frozen once again. Oh, now it works. Okay, great. So 0.04 is going to be your center for those two combined together. The spread is the standard deviation. With that, I believe we have the standard deviation of the original, which is 0.47. Square it, divided by 500, plus 0.51 squared divided by 400, and you square root the whole thing to find the standard deviation of them both being combined together. Oh, I'm sorry. This is proportion, so we need to do it a little bit differently. So it's P times 1 minus P, P times 1 minus P, and when you add them up, so this here would be 0.47 times 0.53 over 500, plus this would be 0.51 times 0.49. I'm running out of space, but that's 49, everybody. I'm going to just use the calculator here. So 0.47 times 0.53 divided by 500 and 0.51 times 0.49 divided by 400. You add up with this and then you square root the whole thing and you get this standard deviation. The spread is 0.03351. And I think that is the correct answer. Yes, indeed. All right, so now with that, let's take a look at the probability that the two sample proportion will differ by more than 0.05. So second VARS, normal CDF. Lower will be 0.05, more than 1 will be 1 because the proportion only goes up to 100%. The mean is 0.04. We found that from part B. It's the standard deviation. I believe we found that was 0.03351. So the percentage of that happening is about 38.26%. And that should wrap up this entire review. I know the answer key says just a little tad a bit different, but they're using the table chart on the formula sheet to get this. So if we use normal CDF, it shouldn't cause that much of a trouble. All right, so hopefully this video helped. I did it before 2 a.m. So this time there's no excuses, I hope. Please watch the video. Make sure you guys study. I'm going to try to make sure that this is not too crazy like chapter 6 test was. I admit chapter 6 test was a bit crazy, 20 multiple choice and 3, open-ended. And this one, I'm going to try to make it as quick as possible. Just so memorize all the formulas and when to use them, and rule of large counts, why it's so important, assume normality, central limit theorem, and all that good stuff. Have a great day, guys. Enjoy the rest of the night, and I'll see you guys tomorrow for the test.